So thank you for being with us. We can start in 1 minute. The audience is just connecting. Hello, Mert.
Bonjour.
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 So welcome everyone. I suggest that we start. The people will arrive in a few minutes. I am Thomas Lodipon. I'm the CEO of Impulse Partner. I am glad that you were able to join. Our goal is to provide an international overview on how tech is developing in digital construction, and we will feature startup companies. For your information, in the coming month, we will have another similar sessions on smart city, energy, and clean tech. Before we start, a few words about Impulse Partners. As you know, we are passionate about innovation in construction, smart cities, and industry. We are lucky to work with some of the largest names in the industry, and we are very happy today to welcome many of you, including Shimizu Corporation from Japan, Gularmak from Turkey, and other investors. Our role is to help detect the most promising startups, connect them with the market. We act as a third party, facilitator between the corporate players, the startup, and the investor. Today's pitch session will be dedicated to digital construction. I can give you a few words about this page, and I'm not going into the detail because it's going to be too complex, but we have listed here all the innovations and the new use that we can believe can have a strong impact on the sector. Obviously, all the key stakeholders in the value chain will be impacted. So we see on the left, the developers, engineering firms, manufacturers, contractors, project owners, and even occupants in buildings. There are many digital innovations that can pop up at different stages of the construction, either at the design stage, during construction, or after construction. Today, we will focus on the few ones that we have highlighted. So we'll be happy to have with us 3D printing with Cobot, environmental simulations with one-click LCA, generative design from Paragroup, robotic production and customization with Ribartech, and 3D scanning with SGRP Tech. Sorry for that. So very happy to have all of you with us. I will give the microphone to Zineb, who is just next to me and who will take care of going through the pitch sessions with startups. Thank you. A great session. For your information, the session is recorded. Yeah. So if you want to refer later to the session, you can. And also feel free to ask questions using the chat so that the entrepreneurs can directly answer your question, or that we can come back to your question. Enjoy the session and use it.
Thank you so much, Thomas. And as you can see, thank you first for joining us. And today we will have the opportunity to cover an international panorama of solutions in the sector of digital construction. So we are so thrilled to introduce you and to present you some of our startups of our ecosystem. As you know, Cobot will start the presentation on the session. Henrik will give us the opportunity to know more about his startup. Then Alibi will present one-click LCA. Then we'll have the chance to listen to Bracha, who will present Para Group. Then Maximilian will present Rebartech, and finally Miroslav will present us SGPR Tech. So thank you so much to the speakers to be here today and to give us the opportunity to know more about what they do in digital construction. So Henrik, the floor is yours.
Thank you very much. My name is Henrik Don Nilsson. I am the founder and general manager of Cobot. Next slide, please. We actually don't call ourselves a startup anymore, Impulse, just notice, because we have been moving so fast and been so successful that we actually define ourselves as a young company now, not a startup anymore. Because in essence, what we are globally leading the 3D construction printing market. We are the ones that are supplying most printers out in the market, approximately 30 so far. And that's what we do. We do robotics 3D construction printers. Oh, that's too fast. Robotics 3D construction printers that are based on the gantry system that are capable of printing the entire building. Can you go back one slide, please? Whoever is controlling it. Yeah. No. Can you go back one slide, please?
We did, but maybe you have some lag. We are on the executive summaries page.
Okay. Good. Then I can just continue from my head. We are doing basically what we're doing is enabling faster, cheaper, and safer construction with more form freedom and the use of less materials. In essence, housing has been at the center of the attention for the market and the customers, but actually not for us. We are basically looking at all concrete applications, including infrastructure, windmills, etc. We are based in Denmark, but 50% of our team is international. And as you can see on me, I'm not a young kid. I'm an experienced manager from blue chip companies. My CFO likewise. So we are coming from Maersk and Velux and have been industrial managers for many years. We're more than 65 employees. And of course, one of the major track records for us was that Perry, in essence, the manual competitor to casting on site, they joined as a minority shareholder in 2018. So basically, Perry was saying, we cannot beat these guys in Denmark, so we better join them. As I said, we've been profitable since 2019. We doubled in size in 19, we doubled the size in 20, and this year it went all bananas, so we tripled our size this year. So it's going very, very fast. And this is, of course, because of our unbeatable track record. So our printers are behind Europe's first 3D printed building on one floor, the first 2-floor 3D printed building, and the first 3-floor 3D printed building. We also behind the first 3D printed buildings in Africa, the first 2-story building in India, together with Larsen & Toubro Construction. And then, of course, also behind the first ever 3D printed windmill tower in cooperation with the GE. Next slide, please. So I still can't see it, but I know what it says. So our customers are spread around the globe, as you can see. Actually, this year, Asia is among our biggest markets. 2 sales to Japan, including JDC, that I'm sure that Shimizu is familiar with. JDC, Japanese General Corporation. And we are in the process now of setting up subsidiary sales companies to service our global market better. So we're setting up in Malaysia, in Dubai, and in the US. And as you can see, we have some pretty good customers like GE, JDC, Lafarge, L&T, Emaar in Dubai, Perry, and so on. And basically, they are spread across a different sectors: construction companies, windmill manufacturers, precast plants, EPCs, so a very heavy concrete application, real estate developers, and of course some universities and R&D organizations. Next slide, please. Yeah, I'm not seeing it.
We are seeing the page, so maybe you have a problem, but
okay.
Yeah, on the 4 main reasons.
Okay, yeah, there are 4 main reasons for the growth that we are seeing, and this is basically also driving our growth, but the growth in 3D construction printing. One of them is, of course, the ability to save on labor. That means it's automatic, so it takes care of that. And secondly, of course, that in all countries in the world, and I know in particular also in Japan, there is a problem with that you don't have a skilled workforce, enough of it. And especially in Japan, they are growing older very fast, and you're not recruiting enough young ones. So we are running out of skilled workforce. If we can put the skills into the printer, then we can overcome that problem. Obviously, with automation also comes less accidents and more precision. And one of the key features is also, of course, this speed that we can have faster execution, and I'll come with a few examples on that. Form freedom has also been driving a lot of the demand for the printers, that we are able to give shape to concrete that the traditional industry is not. And then of course, sustainability, less waste and less materials. Can I have the next slide, please? Yeah. So the specific reason for our success is our Bot 2 construction printer that you see a rendering of here on the left, and on the right-hand side, you see actually the biggest that we supplied so far, which was 27.5 meters in length and 12.5 meters in width and 10 meters in height. Notice the container, the red container standing there, and notice left of that, the people walking around. You can see this is a big mother of a printer. It weighed 17 ton. And it's based on a modular system of 2.5 meter modules. So with that, we can build it to a maximum of 15 meters in the length, 10 meters in the height, and as long as you like in the length. So 15 meters in the width and 10 meters in the height. It comes with 12%. So next slide, please. It comes with 12 specific advantages. That means that you can get, because of the modularity of the printer, you can get actually the size that you need, so we can fit that completely. Obviously, it comes EU certified, IP66. You can operate it outside in rainy conditions, and then we have this extreme speed of up to 1 meter per second. You only need 2 operators to operate it with, 3 if you're doing your own concrete. And this is one of our specific advantages, is that we can actually print with real concrete, not these mortars that are very expensive, but real concrete mixed on site or pre-mixed in a batching plant and then made 3D printable. Obviously, because of everything we have supplied, we have full documentation, manual guides, and we have another advantage, which you see the pictures of illustrating that, which is the flaps and tangential control, which means that we can sort of smoothen the walls, because we put flaps on the sides and we can control the direction of the print head. And there's a lot of other advantages, but we will skip them for now because we don't have an endless amount of time. So next slide, please. Here you see an example of one of the projects that our customers have done. It's very important to notice that we are not a general construction company. We are a tech supplier. We are like Caterpillar or Manitou. We supply the technology, other people are using it. And this is an example from Germany, where Peri printed a 160 square meter building on 2 floors. It took 36 days, not particularly impressive, especially the ground floor, they had to get used to it. And it went a little bit faster, as you can see on the top floor, where it only took 8 days. But it's fully permitted, and buyers are moving in as we speak. Here we see, can I have a next slide, please? So here we see the biggest building so far made with our printers, which is a 380 square meter building on 3 floors, made in Germany. You see already there, Peri, this is the second project of Peri. Already there, they improved quite a lot. They were down to 21 days. So that means basically 60–70% of what they used on the first building, although the building was more than twice the size. So in essence, they improved productivity quite an amount of times. And again, it's fully permitted. Next slide, please. And this actually is one of the key lessons that you should take home here today, is that power of experience. And I'll give you a couple of examples. If you look at the left-hand side, you see the start of the printing of Europe's first 3D printed building, and please play the video. So this was done back in 2017, and we were amateurs. We really didn't know what we were doing and so on. And we made a lot of mistakes, to be honest. Everything was done in the open. That's how we are. We always tell honestly about our results, and we were not very satisfied because it took 2 months in total. But we did learn a lot. So by 2019, we said, let's just see, now we have a better printer and we learned a lot. Let's just see how fast we can build a copy of that building. So we printed it again. Please show the video. So one more time, we took it upon ourselves to print an exact copy of what we did the first time. And this time it took 28 hours. So we went from 2 months to 28 hours. And the funny thing is, in fact, on the third day, where we only did 9 hours of printing, we did approximately 9 hours per day. On the third day, we did more than 50% of the building. So that means even during the process, we learned so much that we doubled productivity on the last day, which means everything else being equal, if we have to do it again, we would do it in 14 hours. And that shows you some of the potential of this technology. Next slide, please. So here's another example. When we 3D printed the first windmill tower, which was 100 tons of concrete, and it was a hollow structure. And it's pretty big, as you can see, 10 meters tall. It took 3 weeks. Please show the video. And actually, the most interesting part of this print is what goes on a little bit later on. Right now, we are at the lower part. Everybody's walking around looking at it, but see what happens now. Now we move up in the height, and oh, where's everybody? There's nobody there. It's all automatic. There's one guy standing over there with his phone because he's bored. He doesn't know what to do, so he's just texting his wife. Anyway, it took 3 weeks, and you know, he was super excited, and wow, you did it in only 3 weeks, and you know, I was not really looking that happy. And they said, "What's wrong, Henrik?" And I said, "Well, you know, 3 weeks. I thought it took too long." And they said, "But how fast can you do it?" I said, I don't know, but definitely 3 weeks was too bad. But if we did it again, you know, 4 or 5 times, maybe we could come down to 3 days. So we actually did it again, but a different design. They changed the design, so now it was more than a 50 to 100% more concrete because it became massive. And then they came and said, by the way, we also want you to add 8 tons of reinforcement. So we equipped the printer to be able to deliver in the reinforcement automatically onto the printed structure. And then we printed, you know, almost twice the amount that we did the first time. And we did it in 3 days. So we went from 3 weeks to 3 days, despite the fact that the amount of material almost doubled and we added reinforcement. So massive improvement of the productivity again. Next slide, please. That is actually one of the key learnings here, is that every time you do something for the first time, you will be very bad. And most of the projects we see out there is for first timers, right? And obviously you can't expect to compete then. And it's the same thing when you learn how to ride a bike. Most of the time you were actually sitting down, falling and hurting your knee. The second time you were way better. We were also way better when we copy printed the bot. We went down to 28 hours. Now, by the 5th time, when you were riding a bike, you sort of got the hang of it. And translated to the bot building would mean that we believe we could print the bot building in 8 to 10 hours. And if we did it for the 10 times, we believe we would come down to 4 to 5 hours. This is not even utilizing the full speed of the printer. With full speed, it would take 2 hours. So it's not even utilizing the full speed of the printer. It's just mastering the process of material delivery, etc., much better. There is a couple of economic explanations about that. It's called learning curve and economics of scale, and I'm not going to bother you with that. And with that, I think I conclude my presentation. Any questions, please?
This is a very interesting presentation. We have actually a question from Shimizu, who is asking what kind of work did you provide to GJC in Japan?
We sold them a printer. Unfortunately, as you know, the restrictions in Japan about COVID are very, very strict right now, so we are not allowed to go there and install it. Instead, we have done a lot of installations videos for them that we are sending to them, and they are in the process right now of installing the printer themselves. Obviously, Shimizu is like, I've seen some of the work that you have done from Shimizu, which is about columns and you know, reinforcement and concrete structure, heavy concrete structures. And that's the same that they are going for. You know, they are doing things like oil plants or gas plants or fertilizer plants, etc. So a lot of concrete structures of various kinds, water storage tanks, pipe sleepers, support structures of concrete, etc. And that's the kind of, we did some tests for them to prove that the technology could be used for these applications. And so they are applying it on a specific project I think it's up north of Tokyo, but I'm not completely sure about that because again, we are not able to visit right now. So right now it's not so interesting for us where in Japan it is. But yeah, we think it's great because we have a customer that is focused on more, let's say, industrial and concrete application, not just this housing market, because we actually think the housing market, yeah, it's interesting, but it's not the most interesting application of the technology. Our advantage is that we can do the whole thing at once. We don't need to move the printer. It takes 8 hours to set it up, yeah, but once you set it up, you don't need to calibrate every time you move the printhead, etc. It's already auto-calibrated. And that means that we can do much bigger structures, much more complex structures, etc., because we don't have to subdivide it into parts that are then casted together. We can print the whole thing in one go, and including doing the reinforcement also. I hope that answers.
Yes, I think it does. Do not hesitate to ask your questions just by speaking and or by writing your question on the chat, like Shimizu just did, asking you, do you think you can make a foundation of offshore wind?
Yes, definitely. And we actually have an ongoing research about that, initial research about that we have started. And we also applied for some funds under the Horizon program. Which essentially is also with GE as the customer, but with some leading universities in Japan, and actually as with JDC as an advisory role in that project. We don't know if it will be granted yet. Actually, when we printed the bot building, we also printed the foundation, because the foundation in essence is just you just print the external perimeter of it, and then you cast out concrete in between that perimeter. So that perimeter, that external small wall, will hold the casted concrete. And one of the features that we are building into the printer is the ability to either print or cast. So that means pour. So that you have one print head that does the printing, but when you need casting, you put in another head, which is a pouring head. And then that does casting of concrete, because any horizontal structure doesn't make sense to print, and some vertical structures like filling up also doesn't make sense to print. It's much faster to cast. So we've also developed a pouring head that we can put on the printer. So it becomes more like a multifunctional robot than just a printer. I hope that explains.
Yes, it does. I think it does. Do not hesitate. Once again, if you have another question, we have another one on the chat. Could you make reinforcement concrete building by this printer?
Yes, yes, it's being done all the time. There are various ways that you can do it. You saw some of the German buildings, and there they have done a lot where they have printed the walls with a load-bearing material, but in certain of the places, the authorities wanted to have that reinforced. So they have lifted a reinforcement mesh down in between two printed walls and then cast it out between the walls. That's one way of doing it. The way we did it, and the way we recommend most of our customers to do, is to print in essence, a little bit the same like you did in your project in Japan. You print a column, you stick vertical rebar into that, and then you cast it out. So then it's not the walls that are load-bearing, but it's the columns that are load-bearing. Obviously, if you don't have solution for the reinforcement, you don't really have anything in the concrete world. So we are working a lot on reinforcement solutions together with GE. We actually, as I hinted at, we're actually looking at the automatic application of reinforcement solutions by the help of the printer. And then, as you have also done, printing with fiber can be an alternative for certain applications. That's it from my side. At least I hope that answered that question.
Yes, thank you. I have an additional question. When you sell a printer to your client, can your client do whatever he wants? Do you have like if he wants to test reinforcement and something?
Yeah, sure. They can do everything, and we are actually trying to establish sort of experience forums between our customers, so that they are sharing ideas and so on, because we have so many customers now globally. And one idea that has been applied, take in Japan, can maybe be utilized by the guys that are in Dubai, or maybe the solution that they found in the US can be utilized by the guys in Japan. So we are connecting all our customers and promoting experience sharing between them. because we will actually not be the experts on the uses of our printers anymore, because our customers will gain so much experience with what works best for them in their conditions that they will become bigger experts than us. So therefore, it's very important for us that this expert knowledge that each of our customers are gaining, and they're not in competition with each other, that they are willing to share that with the others, so that we sort of mature the whole industry and everybody learns from each other.
Thank you.
Thank you. And another question from Shimizu: is the product mainly marked towards area with high labor costs?
I would say originally that was our intention, but we have got a lot of surprises as we went along, because if you look at last year, actually Africa was our biggest market last year, and we did not really see that coming, to be honest. But that's because of the speed, and the getting rid of the need for a skilled workforce, because skilled workforce is a huge factor in Africa, that they simply have so low skill levels. And speed is another huge factor. So these two factors, not saving on the labor, but actually getting rid of the labor because they don't show up, they're not skilled, and so on. Well, and the speed was most important in Africa. So right now we are selling everywhere: South America, US, Middle East, which is of course a little bit higher price market; Africa, low price market; Southeast Asia, which again is low cost market; Japan, which is a high cost market. So we're all over the place, so to say.
Okay, thank you. And another question: is it possible to use concrete that absorbs carbon dioxide from Shimizu again?
Yeah, this is obviously, our customers, like your question is expressing here, is expecting a lot from us, in terms of being experts on carbon capture and other things. But it's definitely an interesting area that we have started to become interesting. I would say this way: if you have a concrete that normally can absorb carbon in a conventional application method, using a conventional application method, that same concrete we can help you to make 3D printable. And then in the 3D printable version, it should also be able to absorb the carbon concrete. And allow me to answer like that, because to be honest, I'm not an expert in carbon capture. So I'll just say what we have learned is generally, if we can get it to work conventionally, we can also get it to work in a 3D printable way. Okay.
Thank you so much, Henrik. Is there another question maybe, or can we go on to the next startup / solution enterprise?
I was not a startup, remember?
Yeah, that's why I said / company. Okay,
thank you.
I think that's it. Thank you so much, Henrik. We'll have time at the end to have more larger conversation, questions, discussions. So do not hesitate if you have some time to stay with us. And if not, of course, you have all the contacts given so that you can communicate on your own, and we will be more than happy to make those relationships work. So now, Aditi, thank you so much for joining us and for introducing us to One-Click LCA.
Thank you. So hello, everyone. My name is Aditi, and I am representing One-Click LCA over here. So to start, this is a software that is basically helping in decarbonizing the built environment. And why we need this is mainly because, sorry, next slide, please. Yeah, so the reason why we need this is we all know that 35% of global carbon emissions from the construction industry are only coming from the construction industry, and buildings mostly account for most of those emissions during their life cycles. So the decisions that we make in projects actually determines the emissions for many more years to come. And here you can see we have identified some challenges that need to be tackled, which are present right now in the construction, carbon and sustainability. And all of these challenges are in a way broken. So for example, there is incompatibility between the BIM tools that are used by different design teams or sustainability teams. There's also a fractured value chain. there is information on data which is in different programs running simultaneously. So overall, it's quite broken. And what we try to do, next slide, please, is we are striving to bridge the gap for real for the construction industry, and hence the software that is able to provide the tools to be able to decarbonize it. If you go to the next slide. In a way, we power the makers and companies like you to quantify embodied carbon impacts, which is the most talked about right now, so that you are able to make knowledge-based decisions where you can also tackle scope 1 to 3 emissions to meet your climate strategy targets, as you already have in place right now. And you can that also helps you to stay relevant on the market by mitigating climate change risks. So we power you to enable you to make decisions towards a more zero carbon future. Next slide, please. To summarize, we are one of the leading low carbon construction LCA and EPD software platform. We have a global presence, as you can see, in about 110 plus countries, and we are headquartered in Finland, but with also our local staff being present in various other locations around the world as well. Next slide, please. What we try and strive for is work towards the market transformation at all levels to be able to create the business environment, and to do that, we deliver software, services, data, and solutions. So regulators and investors can use our tools for getting data, for example, from builders and designers. Builders and designers in turn can use the tools to have and create regenerative projects or design projects that are for net zero carbon. And then in turn, they can also speak with and talk with manufacturers to get information on those data, on those materials for their products that will be used in different building applications. So next slide, please. So we provide the tools for different stakeholders that are present in the construction industry value chain. As you can see over here on the left-hand side, our software is a cloud-based software, and material suppliers that you may have already in place can use our product level tools for doing carbon footprinting of their products. And this data that they gather from the carbon footprinting can be in turn used, if you see in the middle column, can be used to use that data in building design and construction. This, what it does is it would in turn allow your sustainability teams that are working on these projects to use the software for embodied carbon or LCA or different circularity assessments. And on a company level, using this information, you can report on the GHG emissions and steer and move towards your own climate strategy solutions that you have in place or you are striving for. Next slide, please. To be able to use all of these different tools, of course, you need to have a global database, and that is exactly what we provide. So the database that we currently have has more than about 100,000 plus data sets, and that includes data from all over the world, which is both environmental product declarations, so which has EPDs, which have been calculated, so your product footprints have been calculated for the products, and which is also generic data. As you can see, there are different program operators that work around the world. And what we do is we verify and update the data and then only add it to be able so that your sustainability teams can use that in their projects whenever they have any construction related projects to be used. Next slide, please. So when it comes to just going a bit further into this, your material suppliers that you normally work with, because Shimizu, of course, is a very well-known corporation. So you definitely have various material suppliers. In addition to the data slide that you saw before, which is publicly available data, you can also ask your building material suppliers to provide you the information directly from the tools itself. And we have these specific tools that they can use to give you that information in terms of data. So currently with the pre-verified environmental, with the pre-verified tools, they can have a very straightforward way of getting their environmental product declarations done as well. On the right, you can see that we already support a number of different product categories, but we also continuously add furthermore, depending, of course, on the client requirements. Next slide, please. On the buildings and infrastructure side, like I mentioned, your designers and architects that work on different construction level projects can use the tools that we have and that you can see over here as well for all different stages of the construction project. So right from your strategy phase where you want to quickly get a carbon estimate of your project itself, right up to the as-built phase where you want to go more into detailing of the LCA as well. Then it also works with a number of different integrations, which are quite common in the construction industry. So for example, various BIM, building energy modeling systems, or then information modeling systems like Revit or Trimble or IES or Design Builder. Those are also the integrations that we support and that you can use to deliver low carbon projects. Next slide, please. Furthermore, we're also supporting all the national as well as the global systems and standards on both the building as well as the infrastructure level. So here you can see the most commonly used certifications that are seen, for example, around the world. For example, with Asia Pacific, mainly Japan, it's quite common to go for LEED certifications as well, or any others. For example, in China, there's Green Mark. In Singapore, there's Green Mark, and China, there's Building Label as well. But the most common ones, of course, are supported as well. Same case as well on the infrastructure side. So you have different infrastructure LCA tools that you can also use with the software. And next slide, please. Because of the availability to use so many different options, the software is chosen all over the world by leading projects and organizations to carry out projects which are both on buildings as well as on infrastructure. So here you can see a number of projects that have been done using the software. To highly just point out a few of them, you can see Bouygues International, for example, uses the software for their global climate strategy. As well. Then there, in addition, so both on the buildings and infrastructure side, HS2 project, which is one of the largest projects in London so far, also uses the software to understand embodied carbon, its impacts, and LCA. Next slide, please. So overall, to give you a bit of an idea, we work with builders, investors, and contractors like yourself, and we try and bridge the gap between the different stakeholders in the construction chain industry. On an Asian and Japanese market perspective, we have been working with different engineering firms. So they have been using our software in order to deliver these projects. For example, Wunerf, which is a Japanese company, as well as Izumi Systems Planning. There's also Sumitomo Forestry that also use the software as well. And then, large corporations like Arup and Stantec that have local offices in different regions in Asia, for example, also use the software. So that's what we also try and work with, is working and being able so that the industry is able to receive and share information throughout the software and from the different stakeholders like engineers, architects, builders, and investors. Next slide, please. So to summarize, what we can help you with is in driving your sustainability strategy globally by being able to provide you with a holistic set of tools that your sustainability teams can use, because it integrates to almost all different applications that are commonly used in construction level projects. It also has all the global database itself and the compliancy with all the global standards, and covers, and most importantly, covers the entire value chain itself, so that you are able to share your projects, manage your own portfolios, and share information and data and get data as well. Yep. So to say that, I would just say thank you, and please let me know if you have any questions.
Thank you so much, Aditi. Of course, do not hesitate to speak up if you have questions. We have a remark, a comment actually on the chat from Shimizu saying, super interesting, reducing embodied carbon is our responsibility. Now my colleagues in building construction division and sustainability team are trying to make a system internally, but I think it is easy to adapt to your solution. So thanks. Does anyone have questions, comments, maybe? Do not hesitate to type down your questions on the chat, and of course, we'll have also the opportunity to get back to them at the end.
Thank you, Aditi, for this great presentation. How can we engage with you? How can a customer engage with you? They just contact you, and do you have sessions?
Yes, of course. So if you go to slide number 15, probably. The slide before this one. Sorry, after. Yes. One more after. No, down. Before the last slide, the second last one, I have my contact details there. Okay. So they can just directly send it or call me as well.
We have a question in the chat on what is Izumi architecture? I mean, are they a customer or supplier?
They are our customers that use the software for different assessments. So depending on what type of projects they also use it for, their clients have. So for example, embodied carbon or LCA circularity assessments, where they can, responsibly track the sourcing of materials and the end of life phases of the different materials. So then they can construct more circular buildings as well. So plan for that as well. So they have different applications and they use the software for that.
Perfect, thank you. Another comment/question. Yes, indeed, I believe this is perfect system to evaluate embodied carbon in the whole supply chain of buildings. Are there any customers integrating your service into PDFMA platform?
I'm sorry, which platform again?
PDFMA. It is written on the chat. I don't know if it's
I can just check.
Rings a bell.
All right, I don't think I have access to the chat, but I can reply directly maybe once or if you have it.
Yes, it's the letters P, then DFMA.
PDFMA, right?
Platform approach to design for manufacture and assembly, actually. That's what it stands for.
Ah, right. So currently we don't have anyone that is using this for that purposes so far, at least, but we do work with different associations as well. So manufacturing associations as well. Yes, some like in some of our circularity tools, for example, you can use and also add in information in regards to assembly and disassembly as well of different products that happen. So if there are products that are manufactured in a certain way that account for disassembly as well, that is something that you can use with the system.
Okay, thank you. Is there any other question? If not, of course, write down your questions. We can come back to them at the end of the session. And then I'll give the floor to Boacha, who will present us Paragroup. Thank you so much for being with us.
Hi, good morning. Can everyone hear me? Yeah? Okay.
Yes.
Great. Hi, I'm Bracha, and I'm the general manager of Paragroup. We're a revolutionary company whose goal is to reduce material, time, and costs in construction projects. Today, I'm going to describe to you our services, our go-to-market plan, our business model, and more. So I'm going to start with our services. Next slide, please. Thank you. Paragroup is a company that provides services in the world of construction and design. Construction is one of the oldest technologies, and yet it's the slowest to change. At ParaGroup, we aim to find optimal solutions in order, again, to reduce our time, our material, and our cost. Our services are twofold. Firstly, we can use our state-of-the-art technology. We're able to optimize the preliminary design of any project. This includes high-rise buildings, airports, malls, etc. This technology is also able to create tailor-made optimization software for repetitive design projects, for example, retail storefronts, formwork, and architectural layouts. The second type of service we provide is road design optimization. Again, the goal here is the same, to reduce time, material, and cost for the client, contractor, and the designer. Next slide, please. Thank you. Using AI for design optimization is a new field, but we do already have some competitors, including Arup and Buro Happold. These large companies have strengths, including name recognition and money to invest in their R&D processes. But ParaGroup is new, lean, and an agile company. We can pivot when need be, as well as take on any size project, big or small. These companies primarily work in-house, which gives us an edge to be able to bid on the hundreds of thousands of other projects worldwide. Additionally, we can tag along with these large companies where there are different stakeholders for optimization. Next slide, please. Thank you. Our go-to-market plan is already in action. We have current projects in North America, Israel, and in the UAE. We intend to continue to expand our services in these areas, as well as in Europe, using our board members, finders agreements, as well as our growing reputation. Using our different types of services, we aim to market different places with specific services. Our cross-section optimization, or CSO, is a less expensive service which provides detailed analysis and optimized solution to the client. Our holistic structure optimization gives a more detailed and in-depth optimized solution. Our HSO service is better suited for the UAE market, for example. The potential of each of these services in these 4 markets is quite large, and we are already making strides in reaching our potential goals. Next slide, please. Thank you. As I just mentioned, we offer numerous services, including cross-section optimization, as well as holistic structure optimization. These services are geared to serve real estate developers and contractors. These types of projects can be quite lucrative for us, as well as reduce costs immensely for our clients. Road material optimization is more lucrative than either of those previously mentioned services, as road construction and design is generally not at all optimized. This service is aimed at infrastructure contractors. Our last service, which is tailor-made software, is geared towards subcontractors and consultants. As you can see, all of our services are functional, besides the road material optimization, which is still under R&D. With these 4 specified services, we aim to reduce time and material globally in as many projects as possible. Next slide, please. Thank you. Our financial plan for the next year and a half is to grow at a very fast pace. We would like to increase from 7 employees to 19 employees by the end of 2022. With a larger team, we will be able to increase our workload and take on more projects. This will obviously increase our revenue. With increased income, we can continue our R&D for road material optimization, as well as explore other ways to optimize the construction sector. Next slide, please. Our employees are handpicked. We pride ourselves on finding the best and top-tiered candidates who have civil engineering and architectural backgrounds while also knowing how to code. This unique blend gives ParaGroup an edge over any other company. The founder, Yonatan Lazovsky, had an idea that he was able to nurture into a vibrant company. As ParaGroup continues to grow, as does Yonatan's goals, he is a forward-thinking and revolutionary leader. As mentioned, I'm Bracha Copeland. I am an experienced civil engineer. I worked for many years on the largest infrastructure projects in Israel. Using this, along with my management background, has helped me navigate the construction tech industry. I love what I do and believe in this technology to be the next step in construction. Dor Schreier is our Chief Projects Officer and is our focused team leader. He is persistent and data-driven. He leads our R&D team with direction and purpose. He is an architect by trade, which helps him understand the details and precision needed to correctly optimize a project. The rest of our team is just as impressive and makes ParaGroup the company that she is today. Next slide, please. In summary, ParaGroup provides tailor-made AI-based optimization services for an array of architectural and engineering challenges. Each project receives a specific algorithm that was crafted to answer its most difficult to design and to optimize elements. Whether it's a skyscraper structure, an envelope of an airport, or a solar-based power plant. Our team joins the engineers and provides them with the most novel tools that were created specifically for them and the project. We have traction in clients in North America, Israel, and the Gulf. We intend to venture into the European market as soon as 2022. The overall addressable market value for 2022 is $155,500,000 and we expect it to double by 2024. We provide solutions for any type of construction project, including mega residential projects, road infrastructure, complex monumental buildings, airports, and more. As ParaGroup ventures into the European market, we hope that partnering with the Impulse partners can help us propel our vision. Thank you so much, and we look forward to being in touch.
Thank you so much, Bracha. Does anyone have questions?
Could you give some example of how you work on the project, for example?
Sure. What we do is an example that we did, for example, is an airport here in Israel. They came to us with the facade, the airport facade. They wanted it to be optimized as they were over budget. And we optimized the material that was being used, and we reduced the facade material by 50% in material and cost. So, I mean, they came in under budget. And so that is one example, like how we do it, or
perhaps I can add to the how, the question of the how. That's my job on.
Yes, please.
So hi guys, I'm Jonathan Azovsky from I'm the founder. Thank you for having us here. One of the things that we pride ourselves is the fact that we took generative design or parametric design to the next level. In other words, our novel technology is not only generative tools, but actually we build specific machine learning algorithms on top of them, allowing us to get to optimize the most complex project you can imagine. That means if you can optimize, for example, a facade in a building, that's one thing. But if you can optimize a facade and an infrastructure, or I would say a power station, as we did before, that's a very different level of amount of parameters and complexity. So I think that what I'll try to say here is that we take the optimization, the design optimization to the next phase and deep as we can, by providing basically a service that is being provided already by companies like Arup or Buro Happold, but as a specific service. That means you don't have to take Arup or Buro Happold for each of your projects just because you want optimization. We actually can provide what they're providing, and we can say that we can do it even better, but of course that's need to be proven. Again, the combination between our expertise of AI and software development and generative tools and a team that is composed of architects and civil engineers allow us to actually provide that service that is very unique today. That means I don't know how many of you know architects or civil engineers who actually know how to, let's say, develop AI systems or even simple machine learning systems. So a few projects that we've done, one of them, of course, is the airport envelope, where we help them to create an extremely complex envelope. And because it was very complex, the architects and the engineer couldn't get to a very optimal solution. Of course, that our machine learning based system that we built specifically for that project managed to reduce 50% from what they offered in material and in execution time. More of those, we have a lot of concrete structures that we optimized lately, basically North America and Canada, the Toronto market. So we are trying to take that tech and say we can basically take those algorithms and we can tailor them to any type of project, from the most complex projects you can imagine to even residential buildings of 20 stories or 25 stories that are still expensive to construct. They are unoptimized by their nature. That means you're probably going to have 20 to 30% over design in concrete for sure. And to basically bridge the gap that nobody's touching actually today, which is all the projects that Buro Happold and Arup are not taking at the moment. I hope I answered the question there.
Yes, thank you. And that means that your client, they need to have a feeling that one of their structure is under optimized and that they can rely to you to make significant savings.
I think it's a consensus in the construction world that over design is something that we have and we're not actually doing anything about it. And again, the only ones who have the capacity are the bigger engineering firms. We are providing that same ability to smaller, I'll say smaller, but still big projects as well that don't have the capacity or the team or the, let's say, the ability to bring in companies such as Arup and Buro Happold. And another word I want to say, because I just talked about, I heard the One Click LCA, which I love their product, is the fact that lately the CO2 emissions issue is very, very strong. And one of the value functions that we're providing is optimization not only of cost and material per se, but actually trying to evaluate how much CO2 can we reduce, and according to our client and his geography, we managed to get to numbers from 10% to even 25% on concrete structure, for example, and concrete is a very, let's say, dirty material. 8% of the CO2 emissions in the world are from concrete. So if you manage to reduce 15% or 20% of the concrete volume in a project, that's massive on the CO2 emissions. Just to add that.
Thank you.
Oh, please.
Thank you so much. Do not hesitate once again to ask your questions on the chat and to send directly your email contacts on the chat if it's easier for you. And now we'll welcome Maximilian, who will present us Rebartech. Thank you so much, Max.
Hi. Next slide, please. So next, there's a lot of next here in my presentation. Rebar is a huge challenge. A big market next, and next 2 more times. It has a bunch of issues, and the biggest issue that we currently see here in Europe is that it's extremely labor intensive and it's very, very hard labor where the people are really getting hurt. Basically, they get chronic injuries from this work. Next slide, please. And another part of the problem is that the value chain is very fractured. So typically you have a designer that is a consultant that does the structural rebar design. Then you have a supplier that supplies the steel. And finally, you have a contractor that is installing the steel on site. Next slide, please. So what we do here is next, we have a parametric design tool that I will show you soon. Then we make the steel similar to how it's done today. And then we have a process that we call prefabrication, where also a known method, you make the cages offsite, and that leads you to finishing the rebar a lot faster on the construction site. And you save also a lot of labor on site. Installing a cage is much faster than single bars. Next slide, please. This is numbers from a highway project here, where it's a project with 10,000 tons of rebar. And in a traditional way, this project takes 2 years to complete. And you spend around 13 million euros on the rebar. These 30 million euros, that is steel, it is labor, and there's also design cost. So in this project, we only delivered like 200 cages. But if we extrapolated the values that we have seen in 2 directions, one is to do the whole project with our technology. And the second extrapolation is to have our technology fully developed. Then what we can see is you can save 2 months of time on the critical path of the project. And that leads the whole savings in steel, in time, in labor is approximately 4.5 million euros. Next slide, please. So prefabrication is a known method. Basically, the whole key point of the prefabrication is that you have to start at the design phase already. And what we do then is that we connect our parametric design tool to our backend that is running on the cloud on Microsoft Azure. And from there, you can click next a couple of times. You see that all the processes that come afterwards for the making the cages are directly connected to the backend and automatically programmed by our design software. Next slide, please. So here's a quick look at the current, or it's actually not the current version, but at our parametric design tool. It's based on Grasshopper, on Rhino. And on the right side, you see a concrete structure. In this case, it is a for a stairs, landings for stairs in a building. And on the right side, you see that if you change the parameters of the design of the concrete, then you automatically change the rebar. But not only the rebar, but also the instructions for the robot, where to weld the rebar, where to place the jig. All this is automatically generated directly from the design. Next slide, please. Currently, we have like a semi-automated process. So here you see the second version of our production line that we're launching next year. And you see a combination of human labor. Currently, the humans are placing the bars, and robotic labor that is welding the bars together. You also see that this is for a tunnel project, and we are currently focusing on like what we call mass production projects, where we make at least 10,000 rebar cages. Next slide, please. Here's a different use case. It's the same production line, but utilized in a slightly different way. So instead of making a lot smaller cages, here we make bigger cages. And you see that, again, it's a combination of human labor placing the bars and robotic labor welding the bars together. Next slide, please. Currently, we have 3 prototype factories operational. The first one in the middle is in Norway, working on a tunnel project. The second one in the left is also in Norway, where we are testing more mass customization projects here. And the third one on the right is in the UK, where we're also working on tunnel project. Next slide, please. Our business model is that you have a type of design for a project, and you typically have a PDF or a sketch on a napkin, or maybe if you're a little more advanced, you have an IFC file. And we take that into our software and program basically the hardware for you and operate the factory remotely for you. For example, the factory that is currently operating in the UK, we went there, set up the factory, teach the rebar workers how to operate the robots. And now we are running this factory basically remotely. So you have the rebar workers on site doing the physical work, and we are doing the programming and the automation remotely from Norway. Next slide, please. Yes, so Rasmus is a global award winner for structural BIM design, for parametric design. And I'm an experienced project manager that has built a lot of concrete structures. Next slide, please. So currently we have 3 prototype factories operational and focus really on mass production tunnel segments. And then the next types of mass production applications that we have in the pipeline is for wind turbines and diaphragm walls. And then in a few years, we will also go more towards the mass customization technology. Thank you, that's it.
Thank you so much, Max. It was really interesting. And Shimizu is writing a comment saying, thank you very much for your interesting presentation. Regarding your parametric model, how can you decide rebar specification like diameter, pitch, and so on? Any structure analysis is implemented through your parametric model?
Currently, we are not doing the structural analysis ourselves. So you would typically have someone that does the structural analysis before us and says the rebar, the steel quantities that you have in there. So in English, we often call this the design intent. They say how much steel is supposed to be in there. And then we would take that and detail it basically into a design that is good for the machines, for the robots to produce.
Okay. Thank you so much. Any other question, comment?
Any mark of interest from Japan, Maximilian? Or?
Yeah, we have had some initial conversations in Japan. One of the big questions that always was is that because of the tectonic and seismic activity in Japan, welding is something that is we understood is not very liked. So the type of MIG welding that we do is not acceptable for the seismic activities. So that's why we have run tests also where we use tying technology, and so to tie the bars together instead of weld them together, and that would be like one of the next steps for these markets.
Okay, so you answered to Shimizu's questions too, asking if you were thinking of expanding your geographical business area to Asian countries, including Japan. And another question is, could you explain a little more about application to wind turbines?
Yes, for wind turbines, basically, there's two applications. One is typically the foundation today of a wind turbine is built in reinforced concrete. So this is one of the applications to supply the rebar basically for the foundations. And the second application is that for very high turbine towers, you typically go away from a pure steel tower to either a hybrid tower or a complete concrete tower. And for that, again, you need rebar. So this is the two applications that we look next for in regards to the wind turbines.
Thank you. If there is no more questions, once again, do not hesitate to write them down. And Max, do not hesitate to send your email too if you want. And finally, we'll hear from, one more question. How many members do you have at the moment?
Currently, we are somewhere around 25 people in our team.
Okay, brilliant.
Okay, bye-bye.
Thank you, Max, bye. And finally, Miroslav, thank you for joining us and presenting us SGPR Tech. The floor is yours.
Hi, my name is Miroslav Trzesniowski, and I'm CEO of SGPR Tech, and I'm happy to present our solution. Can I have the next slide, please? Okay, so briefly, who we are and what we are doing. We are at the moment over 20 people strong, with 7 PhDs in electronics, geophysics, and software-related areas. We have been awarded multiple awards from the EU regarding electronics and technology that we use. We've raised already over $3 million, and we are in the process of starting our commercial rollout. We are already patenting several key areas of our technology, and we are looking for partners to deploy and test our solution. And our solution, next slide, please. And our solution is, unlike in most startups in construction sector now, focused on subsurface rather than what's visible on the surface. So there is plenty of very nice and very interesting solutions from the area of satellite data, drone data analysis, and machine learning and all the cool techs. But there is not so much of information provided about subsurface, and this is an area that we've been already we've been told by construction sector and raw materials sector that this is one of the areas that is very much lacking information. So this is this is an area that is generating quite a risk for the companies from subsurface related industries. Next slide, please. And what we are proposing is a technology and solution built up of two parts. The first one is what we call DI, and this is our proprietary ground frequency modulated continuous wave ground penetrating radar that has many advantages over existing incumbent impulse radars, and it provides orders of magnitude more information about the subsurface structures and the subsurface materials. One of the main differences is that we get information from various frequencies with current radar between 150 and 800 megahertz. Next slide, please. And to make sense of that, we are building also the brain. So the brain is a software that combines advanced visualization tools, geophysical modeling, and deep learning that also helps to make sense of the data. And our goal and something that we are getting into is making 3D models that are not only telling where are the things or where are the materials, where are the layers, but also what is their material. So that is something that you cannot get with anything but actual drillings at the moment. Next slide, please. And because of the technology that we apply, so frequency modulating continuous wave with advanced advanced software, we are able to get to the levels with the current radar. So we can get much deeper with a low frequency version of it, but we are not developing it at the moment. With the current one, we get to 60 meters. We don't see much of a problem with applying it not very close to the ground. So ultimately, we want to deploy it on drones, but we need to work on on the weight of the whole structure. Again, what is also very important is that we have improved signal to noise ratio, but between 100 and 300 times, so 2 orders of magnitude higher signal to noise ratio compared to existing ground penetrating radars. So why does it matter? We could see with our radar underneath a thick reinforced concrete foundation of a building. So something that is undoable for most of all of ground penetrating radars today. Next slide, please. So we are regarding our applications in construction sector, it's pretty much the whole value chain, because as long as there is subsurface information involved, we can be applied, and we are actually in the process of testing those applications with Vinci Group, and our radar can be applied from pre-design phase, so we can give information like this. There is a popular notion of GeoBeam, so we can actually make it happen. So given information about what's going on the ground and help to map it, and then the design of the building construction or railway or a motorway can be built on that. So designer can work on the soil and the underground they know, so they can build the design based on that. So it can definitely significantly reduce the construction costs. During the construction process, we can provide information from unexploded ordnance surveying, which is a huge problem in Europe after the wars, because there is plenty of bombs still in the major European cities, up to information about underground infrastructure, water levels, and even some things that happen to surrounding soil structures in event of high-rise building, because it alters the structures of the soils around it. So there is plenty of applications, and we are, as I said, in the process of testing and applying them. And we will be happy to share this and share this process with Shimizu as well. So next slide, please. That's the last one. So there is we are actually we have it proven that our solution also already works in a lot of construction applications, and like especially those ones related to pre-construction. Thank you very much. So, it was faster than the time provided.
It was perfect. Thank you so much, Miroslav. Does anyone have questions or comments, of course?
Excuse me, Trivey from Shimizu Corporation. Can I ask a question?
Yeah, sure.
Yeah. So, in the currently in the market, there are many type of GPR equipments available now. So for the underground surface detection. So compared with the common GPR equipments, what is the advantage of your system?
Yes, I'm very happy to have this question actually. Most of actually all of the radars available on the market right now are either impulse-based or stepped frequency radars. So they give you information like the impulse is being sent at some frequency, like a very strong signal has been sent once in a while. Comparing to that, our radar is emitting is constantly transmitting with the changing frequency. So what we are getting is information not from one frequency as the current radars have it, but rather from all the frequencies in between. So you can have hundreds of thousands of samples from the same place, but from different frequencies. And this is something like hyperspectral camera comparing to black and white camera. So you can get far more information about the materials with various frequencies, because various materials respond differently for various frequencies of electromagnetic waves. So this is something like a hyperspectral camera for surface. This is one thing. Another one is that because we gather so much information, we are actually having it averaged quite a lot. That's why we are able to highly improve signal-to-noise ratio, and we are getting things that other radars cannot see. So this is one of the there is no magic involved in the fact that we've been able to see through reinforced concrete. The only reason we've been able to see it is because we are operating at the level that is far beyond the noise level for conventional ground penetrating radars. So one of the important things is that we see this color. We have this color vision, as we call it. So hyperspectral vision. We are also having highly improved signal-to-noise ratio. And with this highly improved signal-to-noise, you can build on that. So we can have some of this improvement lost. So that's why we can mount it on a drone. We can operate in more difficult terrain. We can go with faster speeds with it. There is quite a lot of advantages. If you drop me an email, I can send you some more in-depth material about it. So there is quite a lot of improvements over existing ground penetrating radars.
Yes, thank you very much. Maybe I'll send you my email address. I would like to have more details about the system. But one quick question. Currently, what kind of resolution you can achieve I just quote one example. Currently our underground surface detection, we always have problem with those fiber optics. The metal, the pipe, all this is not so much difficult, but the fiber optics, sometimes some this kind of underground surface detection equipments, is always overlook that kind of fiber optics. Especially some fiber optics, maybe just a diameter a couple of centimeters or something. And sometimes this kind of fiber optics is very, very important also. If it damage, it will disaster.
Yeah, I understand. This fiber optics is actually a problem for everything that related to electromagnetic waves. It's also a problem for us because it's translucent. Like the thing that we can see is either a shielding of it, or if it's close enough to subsurface, like if it's not deep underground, we can see it as an empty space. So, but it's mostly for high frequency applications. So fiber optics is a problem for us also. Maybe not as much as for the existing ground penetrating radars, but we will be much better with the layers of soils or densities or waters or things of that sort. Fiber optics is very difficult.
Okay, understand. Thank you.
Thank you.
Thank you so much. And of course, everyone can speak up. We have time remaining. If you have any questions for any of our speakers, and the other way around works too. If our speakers have questions for our participants, do not hesitate to ask them. Or comments more generally. Okay, so I think we can conclude this session. And to do so, I will thank very warmly all of our speakers, Henrik, Aditi, Bracha, Maximilian, and Miroslav, for introducing us to your companies. It was really insightful for everyone. So thank you so much. We're really thrilled to have you on board and that you are part of our ecosystem. Thanks again to all the participants, to Shimizu Corporations, and all of our ecosystem corporate partners in investors to be here today. And as Thomas said, at first we will we are really very excited to have more sessions with you, especially generally with the smart city thematics, then the energy thematics on April, and finally in June with the clean tech thematics. So thanks again. We have some time remaining, so feel free to send your contacts on the chat, and of course to send us emails if you need some contacts. So we will be thrilled to give them to you. Thanks again.